Okay, so first of all, then, what does percentage abundance mean? Sometimes also called relative abundance. It essentially means if I had many of this this substance M, this metal M, then 30% of the atoms would have this mass number, and 70% of the atoms would have this mass number. And what you would do when they ask you the relative atomic mass, that would be what the average mass number is. So let's first of all imagine a different situation. Let's imagine we had metal X, and we had 50% has a mass number of I don't know, 51, and 50% had a mass number of 52. Well, the relative atomic mass of X would be halfway between the two, right? It would be so that would be 51 not 0.2, 0.5. Okay, that's kind of what they're doing, but because the percentages are more awkward, we have to think of a clever way to do it. So the best way to think about it is, let's imagine we had 100 atoms. Okay, and if we did, then 30 of them, of course, would be 203, and 70 of them would be 205. So we've got these 100 atoms, and we think, well, what's the total amount of mass that you'd get from the 30 203 atoms? Well, it's going to be 30 times 203. And the total amount of mass from the 205 atoms would be 70 times 205. Okay, and then we would just work out whatever that is. Okay, so let's do that now. Just pause the video to do that. Right, so we have the total of 30 out of these 100 atoms, 30 of them with 203 each. So altogether they would have this mass number, essentially, or this, yeah, I would say this mass, that many atomic units, and then the 205 would add up to this many atomic units. So next, what you do is you add up what is the total of all 100 atoms. Well, that would be just these two added together. So that would give us 2440. So therefore, 100 of these atoms of different mass numbers have a total mass of that. So what would be the average? What would be the average mass number? Well, it's going to be exactly, yeah. So you're just going to take that and divide by 100. Well, we can see what that is. You're just going to take the decimal point and move it once, twice. So that gives you 204.4. Okay. So I'm going to give you a different one now, of a real one, and see if you can work out what that one is. So this is a real element, and there are two different isotopes of it. One's 35, one's 37. There's 75% of the 35. There's 25% of the 37. So what would be the relative atomic mass of this substance here? So you've got, so you worked it out. You just did 35 times 75 plus 37 times 25. You added the two together to give you that would give you the total of all 100 atoms, if we had 100 atoms here, and you divide that number by 100. So the way that the shortcut here would be 35 times, instead of 75, but 0.75 plus 37 times 0.25, and that would give you the answer straight away as well. You won't have to divide by 100 because you've already done it in these bits here. So that, in fact, is chlorine. So I've said it's Y, but it's actually chlorine. So if you look on the periodic table, you'll see that the mass number of chlorine, the relative atomic mass, is 35.5, and that's because there are two main isotopes, and they have these percentages. Okay.